Swayam Prabha. Digital India. Educated India.
Hello dear friends, welcome back to NPTEL online course on logistics and supply chain management. So today we'll start discussion on another interesting topic which is taken from obviously the operation research, which is assignment problem programming, right. So in this chapter we'll see how we can assign different tasks to different people or other resources, or different tasks on different machines, or we can say this can be extended to how we can assign different markets to different factories, from where we can transport the material to those from those factories to those markets, so that the overall scenario will be optimized. Optimized in the sense means the total cost can be minimized, or if we are talking about the profit function, so profit function can be maximized. So this is the content. We'll just introduce what is the concept of assignment model, and then we'll talk about some mathematical representation, how we are representing in matrix form. We'll use Hungarian method to solve this assignment problem. A couple of examples, numericals I will be showing you, and then we'll discuss about advantages and what are the basic assumptions which are posing kind of limitations on this assignment algorithm, right. So as I told you, the assignment problem is a kind of case of transportation problem only, and if you remember, in transportation problem what we discussed, from where the material should be transported from that particular factory to particular market location. So the overall transportation cost can be minimized. Same way here we are assigning resources to different activities. Like I told you, manpower is also resources. If we have 5 different activities, we will allocate those 5 different activities to 5 different manpower, like 5 different jobs on 5 different machines, right. So this is the basic concept under assignment problem. And because why this is required, because in terms we are limited with the resources. If we are talking about manpower, if we are talking about machines, if we are talking about factories, we are limited with the capacity, right. So how to assign workers to the machine, how to assign markets to different factories from where the material can be transported, and then salesmen to different sales area. Now it's not only the requirement of that particular activity or job, it is also the conditions are lying with the resources side as well. If we are giving a particular task to different manpower, so you should be knowing about the skills, the talent of all the manpower available with you, right. Only then you can match whatever the job requirements are, and then what that person can do, right. So in that way you can see, if we have n jobs to be performed and n persons are available, this is another very important point, that number of tasks should be equal to the number of allocation, means where we are allocating to any, if we are allocating to people, if we are allocating to machines, right. And then once we have done the allocation, before that we should know that what is the cost if I will assign job A to person 1, if I will assign job A to person 2, 3, 4, 5, all the available manpower. Similar is the case with the machines also. If I am assigning this job on this machine, what will be the total cost, right. If I am assigning this particular factory to this particular market, what is going to be the overall cost when we are serving those locations, markets from those factories, right. So the very basic assumption we are assuming here, that the per unit cost is known to us, right. So this is the assignment model, again because this is, I told you, the operation research part which is taken from linear programming problem, and will try to convert this overall problem into LPP problem, right. So Here only one assignment is done, that means one person will be assigned only one job. We cannot assign two jobs to one person. Similar is the case with other resources as well, right? And here what we are doing, because we are knowing with the what is going to be the cost of performing that particular function by individual machine or by individual person, and then the objective is how we can minimize the overall cost, right? So before going further, you can just go through these couple of videos I have shared on this assignment problem, how we are shifting the material from one point to other point, and then we can go further with the next slide. So this is how we are representing this assignment programming problem into matrix form. See, all the resources are written on the row side. So if you are, let's say you are scheduling manpower, so manpower will be written man m1 m2 mn, right? And all the tasks job 1, job 2, job 3, job n are written on the column side, right? This is C11. C is representing the cost of assigning job 1 to man 1 or assigning job 1 to machine 1. C12 is representing assigning task 2 to machine 1. Similarly, we are having all the possible combination, pairwise comparison. What is the cost if I'll assign job 1, 2, 3, 4, 5 n jobs on machine 1, right? And then all these cost on machine 2, 3, 4, 5, all the available machines, right? So if we are knowing what is the cost, right, of performing that particular task on that particular workstation, then we can optimize our function. So as I told you, Cij is representing the cost of resources I to task j, right? So if we are assigning, let's say if we are assigning job 3 on machine 1, we'll write 1 here, and rest of the cell will be 0, because only one assignment will be done in one row and one column. So one job can be assigned only on one machine, right? So same is the case with the other resources. So in that way, if I am saying that this Cij is the cost, and if I will say Xij is assignment, if I am assigning to particular resource, then I will write 1. If I am not assigning, I will write 0. So in that way, the total overall function will be Cij into Xij, which we need to optimize, either minimize or maximize. So this is the objective function, right? Cij is the cost and then per unit, and then whether you are assigning that task to that person or that machine, accordingly you will put 1 or 0. So this is the function we need to minimize. See, it can be maximization problem as well. If this is not cost, it is representing PNN, profit of assigning job n on machine 1. So then that means we need to maximize it, right? So we have two different cases. One is minimization, another one is maximization. So maximization problem we can convert into minimization. We'll see how we can do that, right? So you can follow rest of the algorithm same way, right? So we have discussed that only one machine can have one task, or one task can be allocated to one person or one machine only. So that means if I'll assign all the allocations are done, so if I'll sum up the column values or row values, it will be always 1, right? So because only one allocation is done, right? So same is the case with the rows, so same is the case with the columns. So another important concept here is whether we are getting the balanced problem or not. If we are having 3 machines, 3 jobs, that means it is square matrix. So whenever we have square matrix, this is a balanced problem. When we have this m is not equal to n, that means I is not equal to j, means number of rows are not equal to number of columns, this is known as unbalanced problem. In that case, we need to convert the problem first into balanced. How we can do that? We can add rows or columns, and then we will make the order of matrix equal. Square matrix we need to confirm first, right? So we'll see that special case how we'll make the unbalanced problem into balanced problem. So the Hungarian method is used to solve this assignment problem. So this is the first step. First we need to develop the cost table, like all the assignments. Cost table means all the values we need to find out. So what if we'll assign task 1 on machine 1, task 2 on machine 1, task 3 on machine 1, similarly all the tasks on machine 1, all the tasks on machine 2, these cost values we will record in the matrix, we will fill these cost cells, right. So then if the problem is not balanced, we need to add dummy row or dummy column. Let us say we have this problem. So here, because we have job 1, we have job 2, we have machine 1, we have machine 2, machine 3, because it is not square, this is not balanced, I need to add the dummy job, right. So here the cost value will be assigned 0, 0, 0, right. This is the concept how we can convert the unbalanced problem into balanced problem. So we'll add, either you need to add column if number of jobs are less than number of resources, or if we need to add rows if number of resources are less than number of jobs, vice versa, right. So this is the first step. Second step is find the opportunity cost table. Now what we'll do, along that matrix we'll go row wise. First row we'll check and we'll find out which one is the minimum value in that row, and we will subtract that minimum value from rest of the values and that value itself, right. So when we will do that, we will get at least 1 0 in each row, right. Like let us say this value is 1, 2, 3. So what is the minimum value? Minimum value is 1. We will subtract this 1 from all these 3 values. So here it will be then 0, here it will be 1, here it will be 2. So we will repeat these steps for all the rows. Once it is done for the row, then we will do the same thing for the column as well. So from column 1, 2, 3, n column, we will go one by one, we will find out the minimum value and then we will subtract that value from rest of the values, right, in that particular column. So when we will be completing step 2, in each row and column there will be at least 1 0, because that we are ensuring that this is opportunity cost table, right. Then the second thing is make assignment in the opportunity cost matrix. So how we will do that? First we will examine the rows successively. First we will find out the first row, right, and we will see whether there is only 1 0. If more than 1 zeros, you leave that row and go to the next one, right. If only 1 0 is there, you will circle that 0 and assign that particular cell. Let us say here only 1 0 is there and here value is 1 and 2. So you will assign this value, that means job M is assigned to machine 1 and rest of the zeros in that particular column you will strike, okay. Rest of the zeros in that column or row you will strike off. That means those zeros are now not available for the allocation. So similarly, you will go for row 1, 2, 3, 4, n number of rows, it is done, and then we will go for columns successively. So the concept is very simple. How we will make the assignment? We will go for first row, we will check whether only 1 0 is there. If it is there, then we will encircle that 0 and we will make that assignment that this cell value xij will be 1. And all other zeros in that particular row or column you will strike off. Same is the case for all the rest of the rows and for all the columns. Now this you will continue this task until all the all the rows or columns are assigned, right, all the zeros are circled. Now we will check. So once you will encircle, what is the meaning of encircle? That means if I am putting this square over that 0, that means this particular assignment is done. Similarly, if I am writing this 0 is here and if I am putting square here, that means job 1 is assigned on machine 3, right. Similarly, we will make all the assignments. Once the assignment is done, obviously what was our objective function? Our objective function was summation of xij, cij, right? So wherever we are assigning, we will write 1. If it is not assigned, we will write 0, and particular cell value will be multiplied. So we will find out the total cost. This will be total cost, and once we will achieve the optimal solution, this cost will be minimum cost, right? So now how will check whether the solution is optimal or not? If the assigned cell values are equal to the order of the matrix, right? If you have done 4 allocations, order of matrix is 4, means number of rows or columns, then this solution is optimal solution. If it is less than 4, the order of matrix, then that solution is not optimal. Obviously, you cannot have more than 4 order of matrix, right? That is not feasible, right? That is not possible. So once you will be having the allocation, number of allocation equal to order of matrix, that means each row and each column must be having single allotment only. That means only one job is assigned to one person, that you will ensure. Let's say this is optimality condition, your solution is ended here, so you can give this is the optimal minimum cost of that assignment, whatever jobs, activities we are assigning to different resources. Now the second thing is, what if these are less than 3, if it is less than 4, the order of matrix, then again thing is, we need to revise the opportunity cost table. And how we can do that? There is procedure. First, for each row in which no assignment was made, you need to tick that row, right? Second, examine the marked rows wherever you put the tick. If any 0 occurs in those columns, tick the respective rows that contain those assigned zeros, right? You need to follow this algorithm. Then repeat this process until no more zeros or columns can be marked. Then draw a straight line through each marked column and each unmarked row. The purpose here is, we need to draw the minimum number of lines covering all the zeros. Let's say this was the matrix, right? I can draw another matrix otherwise. Let's say this is the matrix, right? So let's say 0, this is how we have done the zeros, right? So these are, that means these are the final allocation. We have other zeros also, but these are the final allocation. So now let's say here also 0 is there, here also 0 is there, like this zeros are there. Now we need to draw the minimum number of lines covering all the zeros. That means you either horizontally you can draw or vertically you can draw, right? But minimum number of lines should be there. So if it is small matrix, thus just by visualizing that matrix, maybe you can draw the minimum number of lines. But the order of matrix is bigger, then you need to follow these steps, right? And these steps already I have listed, right? We'll do one numerical, how we'll follow these steps. Then how we'll revise the opportunity cost cell. Among the cells not covered by any line, choose the smallest element, right? Where there is no line, we need to pick those cells where there is no line, and where there is no line, like here I think I have crossed all the cells, but this will not be the case because we have allocations less than the order of the matrix. We must be having some cells where these lines are not passing through. All those cells you will find out. We'll find out the smallest element in that, and what we'll do, we'll subtract this smallest element from those cell values which are not covered by the line. That means from those cell values from where this line is not passing. We need to subtract, and we need to add this value where two lines are intersecting. Let's say on this cell, these two lines are intersecting, we need to add the value here. Whatever value is here, we need to add into that minimum value. So minimum value we'll find out, we'll subtract that value from those values from where the lines are not passing, and we'll add that value at the intersection of two lines, right? This is done. Now the elements which are not covered, or cell values which are not covered by any of the line, will remain same, right? So this is another opportunity cost cell, right, table. And again we'll go for step 3 and we'll make the allocation. How we made the allocation? we went through the first row, we'll find out whether only 1 0, if 1 0 we'll uncircle that and we'll strike off all the other zeros in the row and column. This is how we'll keep on going. We'll keep on iterating the solution until we'll reach the final stage. So this is just the flow chart, how we are doing. Already I have discussed. Is the problem maximization? You need to convert the maximization problem into a minimization problem. That how you can do that? If it is maximization problem, you find out the largest value and subtract all the values of that matrix from that largest value, and that is minimization. Now that problem is converted into minimization, the rest of the algorithm will be same. This is how you can do that. Other way how you can do that, you multiply all the cell values by -1. That is another way out how you can convert the maximization problem into minimization, and rest of the algorithm from here will be same. How we did that? Balanced problem, if it is not balanced, we need to add dummy row, dummy columns, and rest of the procedure we'll keep on assigning row wise, column wise, and we'll see if it is allocations are equal to order of matrix, so that means optimal solution. If it is less than the order of matrix, it is not optimal, we'll again go for revised solution. And how we'll find out the revised solution? We'll draw the minimum number of lines, and then we'll find out the minimum value. That value will subtract from all those cell values from where the lines are passing and add those values where lines are intersecting, and those cell values will remain unchanged from where those lines are not passing through. This is simple algorithm of assignment problem. See, this is the problem. So just will not see this whatever is written. This is the problem. We have programs, we have programmers. Here it is mistake, programmers, right? Now I want to decide A, B, C, which is the program I should assign to these 3 different programmers, right? Because I know the capabilities of 3 different programmers, I know how much time they will take. In that way I can calculate how much I am paying to that person, how many days he will spend on that, and then I can find out if I'll assign program A to person 1, that cost will be 120 rupees. If I'll assign B to program A, 100 rupees. If I'll assign C to programmer 2, the cost will be 110 rupees. This is known to us, this is cost matrix. Now the first step is whether the problem is balanced or not. Yes, it is balanced because number of rows are equal to number of columns. Now the next step is we need to find out the minimum value in the row, and we need to subtract that value from all other values. So in here the minimum value is 80. If I'll subtract 80 from 120, 100, 80, it will be 40, 20, 0. Next minimum value is 80, we'll subtract from the rest of the values 0, 10, 20. Next minimum value is I think 110, we'll subtract from 110, 140, 120, value will be 0, 30, 10. Done? Similarly, we'll go for now column. So column here is 0, so value will remain unchanged, right? Here 10, so here I'll subtract 10, 10, 10. Here 0, so if I'll subtract 0, value will remain same. Right. So this is the next table after calculating the the opportunity cost table. Up to this fine. Now what we'll do, we'll find out, we'll do the allocation, and how we decided, we'll go first row whether we can make the allocation. Yes, we can make the allocation, only 1 0 is there, we will encircle this 0. All other zeros will strike off because there is no 0, will not strike anything. Second, now second you can see we have 2 zeros. So for the time being you don't touch the second row because we have 2 zeros. Third, we have exactly 1 0. Again we will assign this 0 and we'll strike off all the zeros in that particular column and that particular row where we have done the assignment. Done. Now you come to the second row again, because this is already we have striked off, so we have only 1 0. This assignment is done. Now this, if I'll follow this algorithm, program C should be assigned to person 1, program B should be assigned to person 2, program A should be assigned to person 3. Now we'll find out what is the cost. Cost will be just whatever the cell value here is, you need to sum up those values, right? So you can, from the initial solution, you can see here 80, here 90, here 110. You sum up this value, this will be the total cost. Now we'll find out whether this total cost is minimum cost, means optimal solution or not. So that means number of allocations 3, order of matrix 3 equal to, that means this is the optimal solution. Done. So in the end you can find out this total. I think this cost was not given, time was given, so we need to minimize the time. If it is cost, we need to minimize the cost. If it is distance traveling from one market to the factory, then we need to minimize the distance. So that's why the initial slide we discussed that this is a special case of transportation problem, right? Another problem is we have 5 machines, we have 4 jobs. Now this is not balanced problem, we need to add one more job, and the cost of that will be 0, 0, 0. So again, now it is balanced. What we will do? We will find out the minimum value here and we will subtract from first row. Here we will find out the minimum value is 10, we will subtract from the row. Here the minimum value is 1, we will subtract from all these values. Here minimum value is, I think, 6, we will subtract from all these values, and here 0, it will be 0 because we have added one dummy row. So no need to find out the opportunity cost table for column because minimum value is already 0. So if you will subtract 0, it will be same. So this is how it is done now, column and opportunity that is done. Now we will go for the assignment. If we will make the assignment, here only we can do that. First row we can go through, we will make this assignment, all other zeros will strike off. Second, we have exactly 1 0, all other zeros will strike off. Third, we have any 0? We don't have any 0. Fourth, we have 0. Yes, we have 2 zeros, we will skip this. Fifth, we have 0, yeah, we have 3 zeros, right? We cannot go for that. Again, now we will go for column wise. So column B, we have exactly 1 0, we will make the assignment and we will strike off all the zeros in that particular row and column. Again, we will go for next column C and we have exactly 1 0, we will strike off all other zeros, done. So how many allocations are done? 1, 2, 3, 4. 4 allocations are done. And what is the order of the matrix? 5. It is less than the order of the matrix. That means this is not optimal solution. Right? Now what we need to do? We need to find out the minimum number of lines. So I told you the concept of drawing the minimum number of lines covering all the 0. I will just show you how we can do that. So first is mark the rows that do not have any assignment. So I think mark the row that do not have any assignment. So I think row 3 is not having any assignment. Rest rows all are having assignment. Second is we need to mark the column that have zeros in the marked row. Mark the column that have 0. Here also 0 is there. I think here is 0. Yes, it is 0. We need to mark that column where there is 0. Only 1 0 is there, right? Okay. Then next is we need to mark the row that have assignment in the marked column. So that means this first row. So this also we have done. So instead of writing here, I am marking here. So we need to keep on repeating until we will draw the, means we will tick all these points, right, row or columns. Now we need to draw the minimum number of lines through all unmarked rows, unmarked rows. What are unmarked rows? In these lines we need to draw unmarked rows. This is also unmarked, this is also unmarked, right, and marked column. So these are the minimum number of lines, right? How many lines? 4 lines we have drawn. Done. After doing that, now what we need to find out? We need to find out all those uncovered elements. Those are not covered by any line. These are uncovered. This is also uncovered. This is also uncovered. We'll find out the minimum value. And what is the algorithm saying? We need to subtract this minimum value from all those elements from where line is passing. That means here also, here, from where the line is passing, right? And add this minimum value at the intersection. How many intersection? This is 1, 2, 3. So at these 3 points, we'll add that minimum value. Once we'll do that, we will be having this matrix, right? Again, now we'll go for allocation. How we'll do that? We'll find out that row and column where we are having only one 0. First row we cannot do that because we have more than one row 0. Second also we cannot do that. Third also we cannot do that. Fourth also we cannot do that. Fifth also we cannot do that. Let us go by column. So only 1 0 is here. We can assign that, and all other zeros in that row and column we need to strike off. Second, we can make the assignment. No, we cannot do that. Third, we can, no, we have 3 zeros now. Fourth, we can do that. No, we cannot do that. Fifth, again, we have 2 zeros, so we cannot do that. So, because now we have striked off one row, again, maybe we can check for that row or column, and then when we can see that exactly where it is happening. So, if you see that, we have exactly this one, we can make the assignment and we can strike off the zeros in that row and column. Then again we can pick the arbitrarily here, and we can, depending upon whatever is the minimum cost out of that. If you are having two different alternatives, right, that means cost in two different cell is same, so that means you can assign arbitrarily, because if cost is 15 rupees here, 15 rupees here, any one assignment if you will make, the cost will be same, right? So you will continue this procedure until all the assignments are done. So now these are assignments, and how many? 5 assignments are there. We have 5 order of matrix. That means this is optimal solution, right? So this way we can assign all the machines for all these 4 jobs, right? So if we will add the cost, the total cost will be the minimum cost. So this is how we can deal with the unbalanced problem. Now, what are the advantages? Obviously, you can maybe solve some more numericals. You'll have more understanding of that, how you can do that, right? So advantages, assignment problem. First is efficiency, minimization of cost. Obviously, we are considering the transportation cost when we are saying this particular market should be allocated to that particular factory, or these 10 markets should be supplied from this particular factory 1, right? So that means we'll find out the cost, we'll find out the time, how much time it is taking to ship that product, and then we can find out the final cell value of making that allocation, right? And then maximization of benefits. Obviously, when we are considering all the cost, transportation cost, labor cost, time consuming for, you are consuming time for doing that activity, all we are doing that. So in the process of optimization, obviously you are minimizing the cost, overall profit will be improved. Dynamic optimization. This works in the dynamic environment. You keep on changing as the real world scenario is changing. You keep on updating your constraints, you keep on updating your resources capacities, because it's not fixed. So today whatever person is capable, maybe tomorrow he is more capable, he is more trained. That machine may be more enhanced capacity. If you are updating the machine, updating the technology, so that dynamic optimization, what today is the optimal solution, tomorrow may change. So you need to work in the dynamic optimization. Reduction of waste. Obviously, when we are optimizing the function, we are targeting to reduce the waste only. And waste here, extra time if you are consuming, extra labor, extra resources if you are consuming, that is waste. Enhanced productivity, because we are ensuring the proper utilization of the resources. So when you are ensuring the minimum time, minimum consumption of manpower, minimum consumption of material, you will be efficient. Clarity. Having said that, mathematical formulation, objective function already we have defined is xij, cij, right? We need to minimize this function. So we are including all the associated cost. So this is clear objective we are having, that this we very precise criterion in terms of the constraints, in terms of the evaluation we are making, the decision making we are doing based on this particular equation, right? So optimization criteria, obviously we know that we are optimizing the time, minimizing the cost, or maximizing the profit, right? Quantifiable matrix, subjectivity is not there, because whatever the best solution is coming out, we'll see that is the objective solution we are getting out of this, right? That this particular job should be assigned to this person and cost will be 150 rupees. Very clear, right? Integration with constraints, because we are considering all the constraints, what are our resources capable of. So that way we can find out the constraints and we can amend those constraints on the objective function. Then easiness, because we know the decision variables, right? And how we can control only binary decision. If you are assigning, you will assign 1. If you are not assigning, you will assign 0. No other intermediary value is there, right? Tabular representation, which is very easy to understand, because matrix, we are preparing the cost matrix, we are preparing the allocation matrix, and in the end we can find out, just multiplying and summing up all the values, we can find out the minimum cost. Scalability, if your business is operating at small scale, you can optimize at that level. If it is large scale, you can optimize the large scale resources, right? Accessibility, so easily you can access it, and because we have decision making softwares as well, you can use the this algorithm and you can quickly find out the information based decisions, like which person should be assigned with which job, so that the overall cost can be minimized. Flexibility, having said that, when I told you we have two different zeros in the same row and the minimum cost is same, means 15, like I told you. So if I'll assign job A on machine 1, cost is 15 rupees. If I'll assign machine C on job C on machine 1, again 15 rupees. That means I'm having that flexibility, I can assign any job on that particular machine because cost is same. So alternatives also you can find out. So constant also, you can keep on changing the constant. Today whatever is the constant, tomorrow the constants will be different, right? If your technology is changing, so today you are limited by capacity, maybe tomorrow you are limited by the demand. You are producing enough, but you are not able to consume that. So then constant is changing. Today you are limited by manpower, tomorrow you are totally automating the production again. So constant is changed. Tailored solution it is providing you, because when you are changing the real world constants, it will change the solution also. So iterative improvement, because step by step we are finding the opportunity cost table and then we are improving the solution. So this is iterative approach. And scenario analysis, what if this will not happen, right? That is important to find out. If this job C is not assigned on machine 1, what is the cost if I'll assign the job C on machine 2? I have to spend extra 5 rupees to do that job, right? So sensitivity of solution, that also you can find out in that way. Maybe sometimes that machine is not available, maybe broken down, it will take time, so you have to process that on some other machine, so extra cost will be there, right? Real time applications, because immediate response, I told you, you can configure your all the constant functions and then real time data you can fed. IoT and sensor based data, you can keep on tracking all the capacity related or resources, availability, requirements, job requirements, your resources capabilities, right? All those you can record in the real time and then you can find out the best solution. So it's not that today if you are assigning that particular job C on machine 2, tomorrow also the same solution will come, right? If those things are changing, your capabilities are changing in terms of resources, if your job requirements are changing, so in terms of customer demand, so then you have to do in that dynamic workforce management, right? So obviously if that, because you are considering the staff skills also, manpower skills also, today you are lacking with that, maybe tomorrow you will train your manpower and then you will come up with the improved skills. Optimal routing and scheduling, because we can know if I'll serve market 10th using factory 1, so that will be the optimal route, right? So I can schedule in that way. So that is optimal decision. So these are some of the assumptions. Deterministic demand and supply, this we should know what are the column side values in terms of your demands in terms of your number of jobs and what are the row side values in terms of your resources, right? This is first assumption, but in real world it is very difficult to accurately predict how many jobs are required, right? Homogeneous task and resources. This we are considering every task is homogeneous, which is not. Every resource is homogeneous, which is not. If I am doing the same job using machine and if I am doing the same job using manpower, difference is there, obviously. Fixed assignment cost. What we are saying, if today I am doing maybe 15 rupees is the cost, tomorrow also same cost will be there, which is not same. If you are upgrading your technology, maybe cost will come down. If raw material cost is increasing, maybe cost will increase, right? No intermediate stops or transshipments. We are considering direct assignments from factory 1 to market 10, right? Intermediary we are not considering, right? Linear relationship. This is the basic assumption under linear programming, that the relationship between the variables should be linear relationship. Non-linear relationship, non-linear programming methods will be there. Capacity constraints, obviously we should know what are the capacity constraints, and then this is single period planning, because right now if I am running the model, iterations, whatever solution is coming is right now is best, right? I cannot say that this is for long term. Clearly we are defining the objective function, because we need to minimize the transportation cost, we need to minimize the time spent on doing that activity, minimize the cost, maximize the profit, maximize the revenue, maximize the share. So objective function is very clear. Another very important limitation of any linear programming problem is we cannot enter the non-negative values. Obviously, -10 manpower cannot exist, right? So non-negative variables cannot be there. Fixed origins and destination. This is another assumption that we are saying this is only the market, this is only the demand, this is only the customer, this is only the resource, but that is not the situation, because locations or customer locations are also changing. So in that way you need to change, you need to consider the dynamism in the environment. So these are all assumptions which are obviously coming as the limitation of this problem, right? So these are the references, you can go for further reading. So that's all for this assignment programming problem. So thank you very much.